Greetings all. This paper is a foundation tier paper from AQA, GCSE Maths, and it's for practice set 1 they released. It's practice paper 1, set 1, which is a non-calculator paper. So what you can do as well is have a look at the video description and comments. Each question on every one of these videos will be hyperlinked, so you can click on to individual questions. I don't honestly expect you to be looking through every single question and spending hours listening to me go on, so you can just skip to the questions you need to have a look at to revise and understand. So that's worth bearing in mind. Anyway, without further ado, let's start with question 1. So this one is asking for 1/5 as a percentage. So circle our answer. So one thing we need to realise is percentage means out of 100. So we can change from a fraction to a percentage by multiplying it by 100. I'll show you a different way in a second. So what we could do is 1/5 and multiply that by 100. Now, if you're multiplying a fraction by a whole number, if the first number is a fraction but the second number isn't, you can always change any whole number into a fraction by just writing it over 1. So if we just rewrite this slightly, just put 100 over 1, then we can multiply this out by just multiplying the tops and multiplying the bottoms. So 1 multiplied by 100, the new top number becomes 100. 5 times 1 is 5. And so 100 over 5, which means 100 divided by 5. So we can do this using the bus stop method, or if you know what it is, you can just obviously write it down. For these 1-mark questions, you don't have to do all this working. I'm just explaining to you why the answer is what the answer happens to be. 5's into 1. 5's too big to fit into 1, so that doesn't go at all, which means that this 1 is still left over and becomes our remainder. So that 0 is now 10. How many 5's fit inside 10? It's 2 exactly. And finally, how many 5's fit into 0? That's exactly 0. And so our final solution is 20. So the answer to this one is 20%. I'll show you another way. If you're thinking, why is he going into so much depth for the first question? It's because I want you to understand the first question and not make easy, silly mistakes early on in the paper. You need to be getting the first several questions done really well and really accurately to pass this, so we can't afford any little slips. Anyway, if I return to what I was saying about percentage meaning out of 100, at the minute, this fraction is out of 5. So let's see if I can build up from 5 to 100. Well, what I could do to make this number bigger is I could multiply the bottom number by 10. But if I do something to the bottom number, I need to do the same to the top. So if I multiply top and bottom by 10, 5 times 10 is 50. 1 times 10 is 10. But as I keep saying, percentage means out of 100, not out of 50. So then think, how could I go from 50 to 100? Well, hopefully you'll see you can just double 50 to get to 100. But if we're doubling the bottom number, we need to double the top number. And so 10 times 2 becomes 20, and 20 out of 100 means, by definition, 20%. Like we said before. 1b, what is 0.9 as a percentage? Two ways of doing this. Well, more than two ways I'm sure, but I'll give you two ways. So we can rewrite the decimal as a fraction. Now 0.9, this is the units, then we have the decimal. The first digit after the decimal represents tenths, so 0.9 means 9 tenths. Now, like I said before, percentage means out of 100. So I don't want it out of 100. Sorry, I do want it out of 100. I want to go from 10 to 100. So what do I do to go from 10 to 100? I multiply by 10. But if I do that to the bottom number, again, need to do the same to the top as well. So 9 multiplied by 10 is 90, and 90 out of 100 by definition is 90%. So this is the one we circle. Another way we can convert is to just directly multiply the decimal by 100. So if we do 0.9 and just multiply by 100, we can get the answer directly. Now if we're multiplying by decimal numbers, and we're multiplying by tens, hundreds, thousands or millions, a number which looks like a 1 with zeros after it, the number of zeros after the 100 tells us how many places, how many digits the decimal's going to jump over. So the decimal started between the 0 and the 9, times by 10, the decimal moves one number, times by 10, again, the decimal moves another number. So one move for the first 0, another move to the right for the second 0. So the decimal will end up being 2 digits to the right hand side. And so first of all it jumps over the 9. Here it's jumping over nothing. Nothing in maths is a 90. Nothing after the dot. So it becomes 90.0. And 90.0 of course is just 90%. Because it's 0.0, we can just forget the decimal part of the number. Question 2. There are 20 students altogether, 12 of which are boys. What fraction are boys? Well, if 12 are boys and there's 20 students, we can say 12 out of the 20 students were boys. Or are boys. So in the same way, if you had a test at school and you got 12 out of 20, how would your teacher write that? They put the first number on top, out of 20. Whatever number comes after the of goes at the bottom. But of course 12 over 20 isn't one of our options. That's because we need to simplify this down. So if both numbers are even, we can always divide by 2. So we can half the top and we can half the bottom. So half of 12 becomes 6. Half of 20 becomes 10. So if we have a look now, it's still not an option, because what we can do again is simplify down to 6 over 10, because again both numbers are still even. So once again we can end up halving the top and halving the bottom. Half of 6 is 3, and half of 10 is 5. Now thankfully, we can breathe a sigh of relief, this option is here. So that's the one we need to circle. So finally what we need to do is circle 3/5. Question 3 simplify 7x plus 5 minus 8 minus 3x. So I'm just going to write this out a bit bigger and clearer. What we've got here is two different things. We've got x's, which we can highlight. Always pay attention to the sign in front of each term as well. X's are one thing. The other thing we've got are the units. So if we just have a look at the x's, we've got 7x at the beginning, and then we're subtracting 3x. These 3x are negative because in front of the 3x is a negative sign. 7x take away 3x means we'd have 4x's left. Now this one over here, the numbers, we're starting with 5, positive 5, and we're taking away 8. And so if we start at 5, but we take away 8, what would happen is we'd end up with a negative number because what we're taking away is greater than what we're starting with. So if we start at 5 and take away 8, take away 1, we go to 4, 3, 2, 1, 0, minus 1, minus 2, minus 3. And so if we start at 5 and count down 8 places, we'd end up at minus 3. And so positive 5 minus 8 becomes overall minus 3. So the x's become 4x, and 5 minus 8 becomes minus 3 when we count from 5 down by 8. And so luckily this is, as you'd expect, in our possible options. So what we need to do is circle 4x minus 3. Question 4, we've got a bar chart to do. And we've got a table showing how 25 students travel to school, walk, bus, car, taxi. So what we'll need here is 4 separate bars for 4 separate modes of transport. So it's important with these ones to be using a ruler. So the first bar is going to be walk, which is 9. So the graph paper is generous enough so that the scale's easy. So we can say each square is worth 1 student. So going upwards, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can make the bars as thick as you like, as long as each bar is exactly the same thickness. With a bar chart, the bars must be evenly spaced and of even thickness. So the second bar for bus is 8, so we'll make this bar 8 high. Car is 7. So again, 7 high for the car. And finally the bus, sorry not bus, taxi, is only going to be 1 square high. So at the minute, that bar chart's useless, practically, because it's got no scales. It's got no scale, and it's got no labels for the axes. So what we'll need to do now is to label each side of a graph. And so these bars here represent walking. So we'll label this one walk. This one is bus. This bar represents car. And finally this bar represents students who got a taxi. Now even that wouldn't be enough, because someone could think, well, is this types of transport which people use to get to work? Is it types of transport people prefer to use? No, it's the ways students get to school. So what you need to do is to label what these are, and what it is the type of school transport or mode of school transport. So you need to label it something along these lines so that the graph makes more sense to somebody that's looking at it without you having to explain everything. So walk, bus, car and taxi are types of transport. Now what we need to do is to label the scale up here. So this is 0. It's probably safest to always start at 0. Not that you have to, but it's probably easier, typically. 1, 2, 3, 4, 5, 6. Keep going up. 7, 8, 9, and 10. And again, what do these numbers mean? Is it the number of people that just love to walk? Is it the number of cats that that walk around or go on a bus? It's fairly obvious what it is, but it still needs labelling. These numbers here represent the total numbers of people, and so what we can say is we can call this one frequency or numbers of people. In fact, we may as well be a bit more specific because it's students, so we can say the y-axis represents number of students. And that will do. So the scale is going up evenly. It's labelled. The x-axis is labelled with a title, and each bar is drawn accurately, and each bar is of the same width with equal gaps between them. And so that will do for a bar chart. Question 5. We've got 3 events to list for an ordinary dice. So first one, roll an odd number. That's been done for us. B, roll a number greater than 6. And C, roll an even number less than 3. Let's say an ordinary dice. So I'm just going to list what you can get on an ordinary dice. You can get 1, 2, 3, 4, 5, and 6. 6 different sides, and you can get those 6 different numbers from 1 to 6. So rolling a number greater than a 6 would mean a 7 or more, which is impossible because the biggest number on a dice is 6. So B is literally impossible. Now on the probability scale, impossible is given by 0. And by the way, certainty, if something's certain to happen, that's given by 1. But because B is impossible, we put an arrow and label that at 0. C, it says roll an even number less than 3. So let's have a look at the numbers on a dice. Less than a 3, how many numbers are even? Well, numbers less than 3 is only 1 or 2. 1's odd, only 2's even. And so the total number of even numbers less than 3, there's just one number out of a total of your 6 numbers on a dice. So the probability of C is 1/6. Now, thankfully, this probability scale has been divided into 6ths for us already, and so we just want 1 notch out of 6 notches along. So once again, we get a ruler and be pointing clearly to this location here for C. So do the arrow, finally after the arrow label it C, and that's question 5 done. Question 6, work out 23.7, subtract 2.5 multiplied by 8. What I'm going to do first of all is just remind us of BIDMAS. Why? Because we've got 2 different things to do. We've got subtraction and we've got a multiplication to do. So subtraction is that one, and multiply sign we've got over here. So what we need to do is the multiplication part of this one first before we do subtraction. And so I'm just going to write it down here. So as I say, we need to work out the multiplication part first. We need to do 2.5 multiplied by 8 first. So if we're multiplying with decimals, one way we can do this is to assume the decimal place isn't there at all and just treat it as a whole number. We can deal with the decimal after. So think of it as 25 multiplied by 8. First of all, 8 times 5, or 5 times 8, is 40. So put 0 and carry the 4 along. And finally, 8 times 2, 8 2s are 16, plus the 4 we carried, would be 20. So our answer is 200. But just remember, that's not going to be our final answer because we had a decimal in the question, really. In this question, we had one decimal place. We had one number after the decimal, so we need also to have one number after the decimal in our answer. So the actual answer to 2.5 multiply 8 would be 20.0. But 20.0 is exactly 20. So what we can do is just say that it's exactly 20. So 23.7 minus 2.5 times 8, we can write this here as 23.7, and we can replace this multiplication part with what it actually is, which is 20. So even though we do the multiplication first, the order in which the multiplication comes into question stays the same. So if the multiplication part comes last, so we still keep it last in the overall order of the question. We just process it first. So 2.5 times 8 becomes 20. Now the only thing left to do is just to subtract 20 from 23.7. So if you're confident, you can just say what it is without having to do any working out, but I'll show you how to do it this way just in case. 20, as I said before, is the same as 20.0. I'll just do the top take away the bottom. 7 subtract 0, we still have 7 left. 3 take away 0, we still have 3 left. And 2 take away 2 is nothing. And so the final answer for this one would just be a 3.7. Common mistake for this question is to do 23.7 take away 2.5 first and get an answer of 21.2, and then do 21.2 times 8 and end up with a massive answer. The mistake there would be to have done subtraction before multiplication and not following BIDMAS. So remember, always process the multiplication before we add and subtract. Question 7. Write these numbers in order starting with the smallest. So if we have a look here, they all begin 2 point something. So that doesn't really tell us anything because they're all the same. It's all 2 point something. What we need to do, it's like a deathmatch. We need to pit each number against each number. But what we need to do is make sure each number we're talking about has the same number of decimal places if we're comparing decimals. So this one here has 3 decimal places, 3 numbers after the decimal. So we need the same for the other numbers. So far 2.3 has just got 1 number after the decimal. So what we can do is just include another couple of zeros, because nothing in maths is just 0. Here Just need 1 0. And the final one, just add an extra 0. So the whole number parts are 2 for each number. That doesn't help us. So now what we can do is just compare and rank the sizes of the decimal parts. And so if I just colour code these numbers first of all, what I'm going to do is just rank the decimal parts. So the smallest would actually be 030, which would just be 30. Next we've got 300, 303 and 330, as I say, just looking at the decimal parts. So out of 303, 300 and 330, 300 is the smallest. Slightly bigger than 300 is 303, and bigger than 303 is 330. So all I'm doing here is just comparing the decimal part only of a number. So hopefully, as we can see, the smallest, after comparing these decimals, is the one at the end, which I've coloured in purple. The next smallest is 2.3. Then we've got 2.303, and the biggest 2.330. But when we write down the answer on the answer guide, just write down the numbers exactly as they appeared before you altered them. So this number here is 2.03 before we added on the 0. The next one is just 2.3. The next one, 2.303. The biggest at the end, because we're starting with the smallest, is 2.33. And that's the numbers put into order. Question 8, we've got some counters in a bag, classic type of question. 12 are red, 5 are green, and the rest of them are white. The counters chosen at random, work out the probability that it is white. So first of all, we're told that we've got 12 red and 7 are green. So in total, 12 red, and 5 green. Comes to 17 counters that aren't white, basically. We've got 17 counters that aren't white. If they're not white, they're red and green. So the rest of them, as it says, must be right. And so 25 take away 17 means we've got 8 white counters. So we've got 8 white counters out of a total of 25 counters. So if 8 out of 25 are white, we can put this into a fraction like this. So that's the relative frequency of white inside the bag, which is also going to be the probability. 8 counters out of 25 are white, and so that's the chance of picking the white counter. Probability is the number of ways an event can happen. So 8 white counters, you've got 8 different ways of picking a white one. So it's the number of ways the event can happen over the total number of possible outcomes. 25 different counters, 25 different possible outcomes. Question 9. We've got a school trip that students are going on. So 110 students go on a school trip each student needs a bottle of water. So they come in packs of 6. How many of these packs are needed? So if they come in a pack of 6, and there's 110 students that go on the trip, we need 110 bottles of water. I'll give you 2 ways. I'll show you 2 ways of doing this. The most direct way is how many times do we need to buy a pack of 6 until we get at least 110. It's a case of how many times does a small number fit into a bigger number. This is going to be a division if you want to do it directly. So what we could do is 110 divided by 6. So we can do this using the bus stop method. 6 into 1 won't fit, and so this 1 is a remainder which moves on to the next digit. So now we've got 6's into 11. 6 into 11 goes once only, but 6 is 5 away from 11. So the next remainder is 5. Finally, how many 6's fit into 50? Well, 8 6s are 48. So we've still got something left over. So it's 18. Now we don't need a decimal, but we do need to just make a note that we've got the remainder too. So that tells us that how many packs are needed? 18 and a bit packs. Now you can't buy part of a pack. You either buy a pack or you don't. Essentially, this tells us that 18 is slightly too low, so we need to buy 19 packs. Otherwise, a couple of students will go short. So we need to buy 19 packs. I'm just going to mention, as I said, a couple of other ways of seeing this question be done. The most direct way, I'd recommend the division method if you could. Another way you could do it would be just to try how many packs would work. And so 1 pack is 6. You know you need 110 bottles, so would 10 packs be enough, for example? Just try something. 6 times 10 is 60. That's nowhere near enough, is it? Maybe try next 6 times 20. Would 20 packs be enough? 6 times 20 is 120. That is enough. But could you get away with buying any less? Well, 120 is pretty close to 110. Let's try 1 less. How about 6 times 19? Now 6 times 19 is just 1 6 less than 6 times 20. So we could just knock 6 off 120. 6 times 19 would give you 114 bottles, which is fine. But if you tried 6 times 18, that would be 108 only. So 6 times 18, knock another 6 off 114, we'd get 108. That wouldn't be enough. So 18 packs isn't enough. The smallest number of packs that would be enough would be 19. So that's why we need to buy 19. A third way, which I really am not recommending, but would work, is you could even do the 6 times table and just keep going until you get to at least 110. So 1 times 6 is 6, 2 packs of water would be 12 bottles, 18 bottles, 24, 30. Just to stress, I'm not recommending this method because just one slip and you're in trouble. But if all else fails and you're really not sure what to do, doing something in an exam is better than doing nothing. So this is like a last resort, I'd say. 48, 54, 60. Still not enough. 66, 72, 78, 84, 90. Add on another 6, 96, plus another 6, 102, getting close now. 108, still not quite enough, but 114 would be enough with 4 bottles spare. And so 114 is the smallest number that's above 110. So what number is that in our 6 times table sequence? It's 1, 2, 3, 4, 5, 6, 7, 8, 9th, 10th, 11th, 12th, 13, 14, 15, 16, 17, 18, the 19th number. It's 6 times 19, which again tells us we need to be buying 19 packs. That's by far the hardest method. It still would work, I'm not recommending that. So we could do it by direct division, which is the quickest, the trial and error approach, or the exhaustive way of just doing the 6 times table entries. Question 10. AB is a straight line. Work out the size of angle X. Before we dive into this one, I'm just going to remind us of a very important angle fact. This angle fact is that when we've got angles which meet together at a point at the same side of a straight line, those angles will always add up to 180 degrees. So these 3 angles meet together here and form a perfectly straight line. So the first thing to mention is that these 3 angles, when we add them all together, will definitely give us 180 degrees. We don't need to guess that AB is a straight line, because it tells us. So let's simplify this. 27 plus 41. Well, what would that be? So, 7 plus 1 is 8. 2 plus 4 is 6. So 27 plus 41, I can simplify slightly and just say that's 68. So 68 plus x equals 180. We want to work out what x is on its own. So we don't really want that 68 there. So what we can do is subtract 68 from each side. X will be 180 minus 68. So 0 take away 8 we can't do. We've got nothing to take away. So we need to borrow 1 from the 8 next door. 1 less than 8 is 7. 1 we've borrowed, we put here. So now we can do 10 take away 8, which is 2. 7 take away 6 is 1. And the final one, we've got nothing beneath it to take away. So 1 take away nothing is 112. So that tells us that angle X must be 112. So the answer for angle X is 112 degrees. Question 11. We've got a centimetre grid, which means that each square is going to be 1 centimetre by 1 centimetre. And we've got 3 different points to plot. So first point A, 3 and 5. The first number of coordinates means how far along. Second number means how far up. So A, 3, 5 means 3 along, 5 up, which is this point here. Point B, none along, minus 3 means 3 down. So point B is here. And finally C, minus 5 means 5 to the left, 2 squares up. So what we need to do here is connect the points to make a triangle. So from here, join this one to that one. And finally, join here as so. So let's just make it clear what we've done. So point A was 3 and 5, which is this one over here. We then did point B, which is 0, minus 3, if we want at the bottom. The final point, point C, minus 5 and 2, is this one here. So that's all well and good, but what's the question actually asking us? It says, what type of triangle is ABC? Well, the main thing to remember is there's only 3 main types of triangle. The first type of triangle is equilateral. If a triangle's equilateral, it means all sides are the same and all angles are the same. All angles, in fact, will be 60 degrees. Remember, 180 degrees in a triangle divided evenly between 3 equal angles. 180 divided by 3 would be 60 degrees. The second option is it could be isosceles. An isosceles triangle has 2 sides which are the same and 2 base angles which are the same. The third type of triangle is called a scalene triangle. S-C-A-L-E-N-E. That means no sides are the same and no angles are the same. So it says, which type of triangle is ABC? There's a couple of ways we can do this. We can just see how long each side is, if you'd like. Also as well, an isosceles triangle has 1 line of symmetry. It's definitely not equilateral, I hope you can see, because that side is definitely shorter than the other 2. But if you're in doubt, the best thing I'd suggest is to get a ruler and measure. So according to my diagram, yours might be slightly different, but the same principle will hold. This length here is about 8.5. That one's just over 7. So that one definitely isn't the same, so it can't be equilateral. But this side here looks to be 8.5. So let's measure the other side. Now that side's exactly 8.5 as well. So what that tells us is that the top side and the bottom right side are the same. So it's got 2 sides which are the same. Therefore, we know for definite that this type of triangle is isosceles. So our final answer on our answer line, we need to say it's isosceles. And that's it for question 11. Question 12. We need to find the value of 2 to the power 4. So the power 4 means we're multiplying the 2 by itself 4 times in a row. And so 2 times 2 times 2 times 2 is what it means. So first of all, 2 times 2 is 4. 4 times 2 is 8. Then finally, the whole thing, 2 times 2 times 2, which is 8, that multiplied by 2 again would be 16. So the final answer is 16. What's happening is 2 is being multiplied by itself 4 times. So 2 times 2 times 2 again times 2. So we can picture it like this. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the one we need to circle for question 12 part A is 16. This is a trap 8. It's definitely not 2 multiplied by 4. It's 2 multiplied by itself 4 times. Massive difference. So it is not 2 times 4. 12b, just as I've mentioned for 12a, 5 cubed is certainly not 5 times 3. So don't fall for that one. What it means is 5 times 5 times 5 again. So 5 times 5 is 25. Only do 25 multiplied by 5. So you could just do it, the long way, just 25 plus 25 plus 25, do that 5 times. Or you could do 5 times 5, which is 25. So put the 5, carry 2 over. And finally, 5 multiplied by the 2 is 10. Plus the 2 we carried is 125. So the one we need to circle for section B is 125. 5 cubed is 125. And part C, circle the value of tick 196. This means the square root of 196. So what we need to think about is what number, when we multiply it by itself, gives us 196. So what we may as well do is just try these options. So, is it 13 times 13? Well, let's work out what 13 times 13 is. So first of all, 3 times 3 is 9. And then 3 times 1 is just 3. Now move on to the next digit. That 1 now means a 10. So because it means a 10, we put down a 0 when we move on to the next line. Now first of all, we do 1 times 3, which is 3. And finally, 1 times 1, which is 1. And we just add up these two numbers. 9 plus 0 is 9. 3 plus 3 is 6. And the 1, 169. And so 13 times 13 sadly wasn't 196. It was 169. It needs to be 196. So let's try the next option, which is 14 times 14. So let's try 14 times 14 now in the same way. So this is doing it the old-fashioned way. Just for the sake of variety, I'll remind you of my favourite way as it happens, which is the Chinese lattice way. So what we can do, because 14 is a 2-digit number, we can do 2 columns and 2 rows. And using this method, what we need to do is to split the boxes from corner to corner. You could have used the method I used first of all. It doesn't really matter as long as your method is solid and you're comfortable using it. Just going to put this in a bubble to make sure the numbers don't run into this one over here. So you can do any box in any order. So 4 times 1 is 4. So put 0 for this one. What's above and what's to the side? It's 1 times 1, which is 1. This box, 4 multiplied by 4 is 16. And finally, 1 multiplied by 4 is again just 4. Now we add these digits up going diagonally downwards. So the first number is the 6. The next diagonal, we've got 4 plus 1 plus 4. 4 plus 1 plus 4 would be 9. The next diagonal, 0 plus 1 plus 0 is just 1. And that 0 at the top is just, obviously, nothing. And so that does give us 196. So that's quite nice, because you don't need to try every single option. 196, that does work. And so because 14 multiplied by itself is 196, that's just another way of saying that the square root of 196 is 14. Squaring and square root are the opposite things. Question 13. Solve 4x minus 5 equals 17. I'll show two different ways of this one. One way, which is quite common and quite easy to understand with practice, is the way where we start with the unknown letter which we're trying to find and do a flow chart. Just take it step by step and just ask ourselves what happens to the number. So what happens to x first of all? Does it bump into the 4, or do we take away 5? Well, the 4's right next to the x. It doesn't say what's happening. If you've got two things in algebra, it doesn't tell you what's happening between them. It always will mean multiply. So 4x means x is being multiplied by 4. Then after it gets multiplied by 4, we're going to take away 5. And the outcome of all that is we end up with 17. Now what I'm going to do is start at the end and work backwards towards x. Because we're going the opposite way this time, we're going to do the opposite process at each step. So this way we were subtracting 5. Opposite of subtract is to add 5 on. So 17 plus 5 would give us 22. But now instead of multiplying by 4, we're going to do the opposite, which is divide by 4. So x will be 22 divided by 4, which we might just want to scribble down here and see what it is. So 4 into 2 doesn't go because 4's too big. So the first 2 is left over. So that 2 is now 22. So now 4's into 22, we can fit 5 of them. 5 4's is 20, but now we've got a remainder. What you can do is you can make any whole number into a decimal by putting a decimal point followed by as many zeros as you need. But in this case, if you've got a decimal here, it needs to line up with a decimal above the bus stop. So now we've got somewhere to carry on the remainders. So as I was saying, 4's into 22 goes 5 times. 5 times 4 is 20, which is 2 away from 22. So the remainder, again, is 2. So that makes us 0 a 20. And the final step, 4's into 20 goes 5 times. No remainder, so we're done. And so x is 5.5. Or, if you prefer using fractions, you can say x is 5.5. The other method I mentioned, I'm just going to copy down the question again to illustrate this other method, is it's a slightly lazy shorthand really, but it does work with practice. It's the idea of swapping side, swapping sign. If you notice here, solving equations, you're often working in reverse, doing the opposite things. So this is just a shorthand version of that. We're working towards having x on its own. So that minus 5 could do with going away, so we can throw it to the other side. But if we swap to the other side of equals, we swap the sign. Opposite of minus is plus. So you can think of it as, on the other side, the minus 5 becomes an add 5. 17 add 5 is 22. Now we don't want 4x's, we want just 1x, so that 4 needs to go away. That 4 is multiplying the x as it stands, so when it swaps sides, it will swap sign. Opposite of multiply is divide. And so x will be 22 divided by 4. Now both of these numbers here we can half. So half of 22 is 11. Half of 4 would be 2. So 11 halves. So we can change that into a mixed number. How many 2's fit into 11? 2 fits into 11 5 times, with 1 half left over. And as I said, we can write 5.5, or we can just do 11 divided by 2 as a decimal, which is 5.5. So the answer, x equals 5.5, or you could write down 5.5. Question 14. You've got John who has 78p and Nat who has £3.52. And Nat gives John some money so that they both have the same amount. How much does Nat give to John? Well, I think the best thing of doing for this question is to realise that after she gives him some money, they both have the same amount. And so I wonder how much money they have in total. So if John has 78p and Nat has £3.52, we can calculate the total amount of money they'd have by just adding these two values up. Make sure you put 78p as 0.78. 78p is not the same as £78. So 8 plus 2 is 10. So put down a 0 and carry a 1 along. 1 plus 7 is 8. Plus 5 is 13. So put down the 3 and carry over the 1. And finally 1 plus 3 is 4. And then we're done, as long as we make sure that if we've got decimals here, they need to line up on the answer line as well. And so the total amount of money they have between them is £4.30. So the total money equals £4.30. Then if they both have the same amount of money, we can think of this total being divided equally between them. So the money they'd each have would be 2 into £4.30. So 2 into 4, we can fit 2 exactly. Make sure the decimal lines up top and bottom. Next number, 2's into 3, we can fit 1, but 2 is 1 away from 3, so we have 1 left over. Finally, we've got 2 into 10. How many 2's fit into 10? Answer, 5 exactly. So that tells us that they each would have £4.30 divided by 2, which I've just worked out to the other side. They'd each have £2.15. The question was, how much does Nat give John? Well, Nat had £3.52. She ends up with £2.15. And so in terms of how much she gave away, if she started with £3.52, then we can calculate how much she gave to John by doing £3.52 subtracted from what she ends up with, which is £2.15. Okay, so £3.52 take away £2.15. 2 take away 5 we can't do, so we need to borrow from the 5. If we borrow 1 from the 5 it becomes 4, and the one we've borrowed goes next to the 2. Now we've got 12 take away 5, which we can do, which is 7. 4 take away 1 is 3. Make sure the decimals line up. Then 3 take away 2 is 1. And so she must have given him for £1.37. So in terms of our question, what it's asking us, how much does Nat give John? She must have given him £1.37. There are other methods for this question, but I believe, in my head anyway, that's maybe the most straightforward. So that's what we need to put down on the answer line. We need to answer in pounds, so be careful you don't put the answer in pence. So the answer is £1.37. Question 15. A cinema's got 37 rows of seats, and there's 23 seats in each row. And so, first of all, what we could do is work out the total number of seats. So the total number of seats will be 37 multiplied by 23. So I'm going to do this in a few different ways, just to recap the different ways we can multiply. So I'm going to return to this bit later on, but first of all, let's have a look at 37 times 23. So this is what I just call the old-fashioned way. It's probably not any older than any other way, but this is the way I was taught it, so in my head this is a bit old school. Still works a charm. First of all, 3 times 7 gives us 21. So we put the 1 and carry 2 on. Then we do 3 multiplied by 3. 3 times 3 is 9, plus the 2 we've carried gives us 11. So now we've multiplied this 3 by all the numbers above. Now we move on to the next number, the 2, and because that 2 represents 20, we start by putting a 0. First of all, we do 2 multiplied by 7, which is 14. So we put 4 and carry 1 on. Put the 1 anywhere, as long as you remember to carry it and add it. And finally, 2 times 3 is 6, plus the 1 we've carried gives us 7. So now we need to total up these numbers here to get our final answer. 1 plus 0 is 1, 1 plus 4 is 5, 1 plus 7 is 8. So we'd get 851. Just to show you that I'm not biased, I'm going to now try the way I don't really like, but it's quite common still in schools. Each to their own, I guess. So this way is where you partition the number into hundreds, tens and units. So 37, and down here we're going to do 23. So just section this one off so we don't collide into each other. Obviously all you need to do is get 851 either way round. So you don't need to do multiple calculations like I'm showing. I'm just showing different methods in case you've forgotten a few methods or want to revise them. First of all, you can do the boxes in any order. So first one, 20 times 30. 2 times 3 is 6. Add on the 2 zeros, gives us 600. This one, 20 times 7. Well, 2 times 7 is 14, plus that 0 gives us 140. 3 times 30 is 90. And finally 3 times 7 is 21. Then in any way or any order you like, what we need to do is total up these boxes. So I'm going to do it the top row first. So 600 plus 140 gives us 740. And 90 added to 21 is 111. So now in the same way, add them all together. 0 plus 1 is 1, 4 plus 1 is 5, 7 plus 1 is 8. I'm now going to show the Chinese method, or the lattice as it's sometimes called. Now the lattice method, it looks the same to begin with as the grid, but what we do, after we split the grid into 2 by 2, it's quite badly drawn actually, never mind. We divide them from corner to corner. I really haven't drawn that very nicely, but as long as you're careful it should be okay. Just try and make sure the diagonals go from corner to corner, and if you struggle with drawing, use a ruler. Now don't write 37, we just write down the digits. So 37 times 23. So again you can do the boxes in any order. 7 times 2 is 14. 3 times 2 is 6. 7 times 3, 21. And 3 times 3 in the bottom left box gives us 9. So because it's a single digit number, you put 0 first and then the 9. Now we add up these numbers going diagonally downwards. So the first one we've got is just the 1 in that corner. The second diagonal line, 4 plus 2 is 6, plus the 9 gives us 15. So put the 5 and carry 1 on. And this one, 1 plus 6 is 7, plus 0 is still 7, plus the carried 1 is 8. So again, this method gives us 851. So returning to the question, I think we've safely established that the total number of seats is 851. So we've got some marks in the bag already. Adult and child tickets are sold. The cinemas sold every ticket for every seat. So 851 tickets have been sold. The managers estimated that 6,400 was raised and 200 child tickets were sold. And so what we can do here is just think about it in terms of child tickets and adult tickets. So for the child tickets, if we're told that 200 child tickets were sold, and child tickets are £6 each, the total money raised from selling off the child tickets would be £6 multiplied by 200. So we can do this as 6 times 2, which is 12, then simply add on the zeros afterwards. 2 zeros here, so 2 zeros added on. And so money from the child tickets was £1,200. Now we need to consider the adult tickets. Now, 200 child tickets were sold. There's 851 tickets altogether. So how many adult tickets were sold? There's 851 tickets altogether, and 200 child tickets were sold. The other tickets must have been for adults. So 1 take away 0 is still 1, 5 take away 0 is 5, 8 take away 2 is 6, and so we've got 651 adult tickets. And each one of those adult tickets is £8. So the total amount raised by selling off the adult tickets will be £8 multiplied by 651. Now I could do the same as before and show you multiple different ways of multiplying these numbers together, but what I'm going to do, I'm just going to show one way just for speed. So what I'm going to do for this one, could flip a coin I suppose. I'm going to do the lattice way, why not? So 651 is a 3-digit number, so we're going to have 3 boxes. We're timesing it by 8, which is just a 1-digit number, so that's just 1 row. Split the boxes from corner to corner, as we always do when we're using the lattice method. Now we just multiply each 8 by what's above each box. So 8 times 1 is 8. 8 times 5 is 40. And finally this one, 6 multiplied by 8 is 48. Now we're going to add up the numbers going diagonally down. So the first diagonal, the bottom right, is 8. 0 plus 0 is 0. 4 plus 8 is 12. Carry 1 across. And finally, 4 plus a carried 1 is 5. So we get 5208. So that tells us the total sold for the adult tickets is £5,208. So what we did there was realise that each adult ticket is £8 and we're selling 651 adult tickets. So the total amount of money altogether from selling the adult tickets and the child tickets would be to total up the 1,200 for the child tickets and the money sold from selling off the adult tickets. So add these numbers together. 0 plus 8 is 8, 0 plus 0 is 0, 2 plus 2 is 4, and 1 plus 5 is 6. So the exact amount of money raised is 6,408, and the manager's estimate was 6,400. So comparing his estimate of 6,400 to the actual, which is 6,408, I'd say that's pretty close. He's only £8 off. £8 is a proportion of... Oops, Daisy, get this calculator out of the way, shouldn't be using that. So £8 out as a total of 6408. That's nothing really. £8 is a drop in the ocean compared to 6,400. So relatively speaking, his estimate is very close. So we need to just conclude by saying something along the lines of yes, his estimate is close. So I'm just going to put his estimate of 6,400 was close, and that should do. A big 6-mark beast finished off. Question 16 says, what is the 3-figure bearing of Leon from Bordeaux? Now my tip for bearings is going to be that whatever we're measuring the bearing from, we pay particular attention to. So because we're measuring from Bordeaux, we're going to start measuring from Bordeaux. And as well, bearings always are measured relative to north. And so this is why from Bordeaux, I've drawn a straight line going up, which represents north. So what we need to do is measure the angle from here to Lyon. So I'm going to draw a line from Bordeaux to Lyon, like this. And so what we need to do is measure the angle from Bordeaux, facing north, until we turn and face Lyon. Now you might be able to see that this angle here is just a bit less than a 90-degree angle. It's almost a right angle. So just by looking and thinking and applying what you already know, you should hopefully have a hunch it's going to be 85 degrees. But the best way of being sure is to use one of these things here and measure. And so we put the centre part of the protractor immediately on top of the place we're measuring the bearing from, which in this case is Bordeaux, and start measuring from 0, 10, 20, 30, 40, 50, 60, 70, 80. That's almost 85. Now why isn't saying 85, I don't know. I can only assume that either I've made a mistake or that this drawing is slightly off. Anyway, maybe it's me, maybe it isn't. But 84 degrees, if it was perfectly accurate, I should be getting 85. But even if you do get 84 or even 83 or 86, you should find that by far the closest one to the actual, even if you haven't got 85 exactly, it's going to be 85. So the closest one here is 85 degrees. Therefore we circle 85 degrees as our answer. I should really say 085. Technically a bearing needs to have 3 digits. Always remember that. You can lose a mark easily. Part B, we're told to work out the actual straight line distance from Paris to Marseille. And we're given a scale as well in this question. Now, you probably notice that a lot of these diagrams in the exams, they say diagram not accurately drawn. Well, two things. It doesn't say that here, so we can assume our diagram is accurate, and also the fact we've got a scale is a massive hint for us to actually measure the distance and convert that to a real distance. What I'd mention here, before we do, is this scale is in the form of one number being a 1, the other number being a number which isn't 1. So that tells us that to change from one to the other, we're either going to multiply or divide by the number that isn't 1. So we're going to times or divide by 80. Now 1 is a smaller number than 80. So if we're changing from a small number to a bigger number, using this scale we've been given, to change from centimetres to kilometres, we're going to multiply by 80 to make sense of this diagram. So what we're going to need to do now is get a ruler, and with a ruler measure the distance from Paris to Marseille. So Paris is here, Marseille's further down at the bottom. So start from 0 and get to measure where Marseille is. So from Paris to Marseille, that's 7, 8 centimetres. That to me looks like 8.2. So from Paris to Marseille, I'd say the best estimate of my distance is 8.2. Now, if you're slightly different, it may well be because of how your particular paper has been photocopied. But this distance here, I'm going to just write down, is 8.2 centimetres. It could be that the photocopying settings have made your diagram a bit smaller or a bit larger, but you should have something in the region of 8.2. If in doubt, check with your teacher and get him or her to come over and measure it. So 8.2 centimetres. We now need to convert this to kilometres by multiplying it by 80. So we need to process 8.2 multiplied by 80. So to do this, I'm just going to use the old trusted lattice method. It might be better using a ruler than being rough and ready like I am. So forget the decimal for a second, we can put that back in afterwards. So we're going to do 82 multiplied by 80. Now any number multiplied by 0 is going to be 0, so this row here is very easy to fill in. The top one, 8 times 2 is 16, and 8 times 8 is 64. Now we can add up these numbers going diagonally downwards. The first one is 0. 6 plus 0 is 6. 1 plus 4 is 5. And 6 on its own gives us 6. And so 8.2 times 80, the answer is going to look like 6560. But remember, the question actually has a decimal in it, and there's one decimal place in the question, so there needs to be one decimal place in the answer, and so the decimal needs to go in between the 6 and the 0. So the actual distance from Paris to Marseille, according to my measurements, is 656.0, but because it's 0.0, we can just say it's 656 kilometers, because a 0.0 can just be ignored, because 0.0 is nothing. So that's my final answer, 656 kilometers. Question 17, we've got some information about a group of children here, boys and girls, and if they're left-handed or right-handed. The first part of question 17 is we need to write down the number of left-handed girls to right-handed girls as a ratio. So, left-handed girls, we've got 8. And right-handed girls that are right-handed, we have 20. So first of all, important to identify which numbers of this grid we're talking about. So left-handed girls are mentioned first, ... and 20 are mentioned second. And so it says give your answer in simplest form. This would get you a mark, but to get the second mark we need to simplify it down. So what can we divide 8 by and 20 by? If you're not sure, you can just half them. If a number's even, if in doubt, half each number. However, hopefully you'll spot that 8 and 20 are both in the 4 times table. And so what that means is we can divide both sides of this ratio by 4 to get the simplified answer in one move. So 8 divided by 4 becomes 2, and 20 divided by 4 is 5. And so as a fully simplified ratio, for every 2 left-handed girls, we have 5 right-handed girls. In part B, it says what percentage of the boys? So percentages, it's always a good idea to be thinking percentage of what? So it's percentage of the boys. So the boys, we've got 3 left-handed boys and 12 right-handed boys. So the total number of boys we've got is 3 plus 12, which is 15 boys in total. So how many are left-handed? Well, the left-handed boys, we've got 3. And so we can say that 3 out of 15 boys are left-handed. So although the question asks us for a percentage, we can start this off by converting this bit of information into a fraction. 3 out of 15 can be written as 3 over 15. So we need to go from out of 15 to out of 100 because percentage means, by definition, a fraction out of 100. Now sometimes it's actually easier to simplify and then make the number bigger afterwards, because 15 doesn't fit into 100, but never mind. Let's see if we can simplify down 3 and 15. Well, both these numbers can be divided by 3. But if we do one thing to one number in the fraction, we need to do the same to the other, just as how you simplify ratios for that matter. 3 divided by 3 gives us 1. 15 divided by 3 gives us 5. So what we need to do is to build up from 5 to 100. You can do this in 1 step or 2 steps. Doesn't matter as long as you can get there your way comfortably. What I'd suggest you do is we can multiply both numbers by 10. 1 times 10 and 5 times 10 would give us 10 out of 50. And then once our bottom number is 50, we can easily get 50 to become 100 by just multiplying by 2. So then finally, if we multiply both top and bottom by 2, 10 times 2 is 20, and 50 times 2 is 100. So 3 out of 15 is equivalent to 20 out of 100, and 20 out of 100 by its definition means 20%. So the answer for what percentage of the boys are left-handed, that's 20% of them. Question 18. Liam reckons that if you divide any multiple of 10 by 2, the answer always ends in a 5. Is he correct? Well, sometimes he will be, but ultimately, is he correct? The answer is no, because he's saying any multiple of 10. So for example, if you were to pick 20 and divide that by 2, 20 divided by 2 would be 10. That doesn't end in a 5, it ends in a 0. So for some multiples of 10 he will be right, but just for as many that he's right for, he'll also be wrong for. 10 divided by 5 does end in 5, as would 30 divided by 2. But 20 divided by 2, 40 divided by 2, and so on, they'd all end in a 0, and so he's not always going to be right. So no, with a calculation to support you. You could have done literally an infinite number of calculations which would be valid. You could have done, for example, 100 divided by 2, which should be 50. But just show one calculation. Don't go wasting your time doing loads. So that would do here, that first line I've wrote down. Question 19. Translations. A translation is when the shape just moves. So it doesn't get any larger, it doesn't get rotated, it doesn't get reflected, it stays the same way up, the same size, but just moves. And so what's happening is, point A moves to point B. So what you might want to get, you don't have to, but it could help, is tracing paper. So here's one I've traced out earlier. And so point A is this top point of the triangle. So what's happened is it's just moved from here down to here. So the triangle would end up in this position. It's gone from A to B. So each point has moved 3 to the right and has gone 3 down. Part B of question 19, we're asked to rotate the triangle 90 degrees clockwise so that point C moves to point D. Again, with part A, tracing paper might help you. So here's some I traced out earlier. So what we can do is we can put the trace shape immediately on top of the shape which is already drawn and rotate it 90 degrees. So 90 degree rotation means you're just going to turn the tracing paper from being on one side to the other side. So I'm going to just turn it on its side so it becomes like this. And that'd be all well and good if only point C had moved to point D. What's happened here is point C, the corner bit, the right angle, needs to be on top of point D. So we need to move it over and just pop the triangle on top of point D there, and then we're done. It's been rotated and it's in the right place. Number 20, we've got a formula, v equals half x squared h. What we need to do is substitute in the values of x and h. And so the formula means half multiplied by x squared. Oops. So multiplied by x squared, and then multiplied by h, because there's no instructions between the half, x squared and the h. So if there's no instructions with algebra, it will always mean multiply. And so we're multiplying, but we've also got a power to deal with. So if I just remind us of BIDMAS, what we'll need to do is to work out the power part first. Powers, the x squared, is the I. Indices is just the technical term for powers. So what we need to do now is to substitute in these values into the formula. So we know what x is. X is 11. And we're told what h is as well, luckily. H is 6. And so this becomes half multiplied by 11 squared multiplied by 6, because as I've just said, x is 11 and h is 6. So before we do anything else, we're best off working out this power of 11. Now 11 squared means 11 multiplied by 11, which is 121. You can try this using long multiplication and you should get 121. So half times 121 times by 6. Now what I'm suggesting we do first of all is the 121 multiplied by 6 part. So doing it this way, any method will do as long as we get the correct answer and you're comfortable in the method, which works. First of all, we're going to do 6 multiplied by 1, which is 6. The next number along is the 2, so 6 multiplied by 2 is 12. Carry an extra 1 on. And finally, 6 multiplied by 1 is 6, plus the 1 we've carried is 7. And so, just filling in this bit, 121 multiplied by 6, we've worked this out and that's 726. So little by little we're just making progress to simplify it down until you can get an actual numerical answer. So 121 times 6 becomes 726. Now what we need to do is 1/2 multiplied by 726. Half of a number is the same as half multiplied by a number. And so multiplication often works as of. So what this means is half of 726. So what we need to do now is just do 726 divided by 2. So we can use the old bus stop method for this one. So first of all, 2's into 7, we can fit 3. 3 2's are 6, which is 1 away from 7, so the remainder is 1. 2 into what is now 12, 2's into 12 goes 6 times, and 2's into 6 goes 3 times exactly. And so finally, we've got 363. So v equals half times x squared times h, which is a half times 11 squared times 6. All of it boils down to, by the end, 363. So for these particular values of x and h, v will equal 363, and that's our final answer. Question 21. I've done a table down here which will make it easier to explain. Diaries are sold in boxes of 12, pencils are sold in boxes of 10, and rulers in boxes of 6. A teacher wants to buy the same number of diaries, pencils and rulers. Work out the smallest number of boxes of each item he could buy. So think about the diaries first. Diaries are sold in boxes of 12. So one box of diaries would be 12 diaries. Two boxes of diaries would be 24. Three boxes would be 36. It's essentially the 12 times table because we're increasing by 12 each time. So be careful because it's a non-calculator paper. Just add on 12 each time and keep going. $96. Add another 12, 108. Go up to 12 times 10, which is 120. Pencils are sold in boxes of 10. So one box would be 10 pencils, two boxes would be 20, three boxes would be 30, and so on. And so this one, as you've probably realised, is just the 10 times table. 70, 80, 90, and 100. And the rulers sold in boxes of 6. So one box of rulers would give you 6 rulers, two boxes, 2 times 6 would be 12, three boxes of rulers, 3 times 6 is 18, and unsurprisingly this is just the 6 times table. 36, 7 6s are 42, 8 6s are 48, 9 6s are 54, and 10 6s are 60. And so what we need to have a look at now is the smallest number of boxes of each item he could buy. And so looking at this list, what number do we see repeating? And the smallest number that's in both is 12 in each. No, 12's in those two but not pencils. 24 can't be because it's not a multiple of 10. Nor can 36 or 48, but 60 might be. You've got 60 here, 60 here, and 60 there. So you've got it cracked. So the magical number of items, because it's the same number of diaries, pencils and rulers, that same number is 60. And that's accomplished if, for the diaries, if he gets 5 boxes of diaries, that would work. For pencils, how many boxes of pencils would he need? Wrong colour. Oh, never mind. Pencils, he needs 6 boxes. Because 6 boxes of pencils are given 60. And finally, how many boxes of rulers does he need? That's 10. So 10 boxes of rulers. Oh dear. And you see, making a mistake is as easy as that. I'll leave this into the final edit because it's good to see that I'm definitely not above making mistakes. It's not 60 boxes of pencils, it was 60 pencils in total. What I meant to say here is the number of boxes of pencils, which is 6. It's as easy as that, so just be very careful. That goes to me as well. So 5 boxes of diaries, 6 boxes of pencils, and 10 boxes of rulers would solve his problem and would give him 60 of each item. Question 22. Which one out of 2/5 or 5/8 is closer in value to 1/2? And we're told we must show working, so we can't just simply guess if it's one or the other. There might be a few ways to do this, in fact there will be. I'm going to show you two. And so one way is I want you to think of these fractions in terms of money. I'll say think in terms of money for two reasons. Money is an easy way to link things to decimals. Also, we use money most days. So because you use it most days, it's something you're more familiar with, and it is likely therefore to make more sense to you. So we've got two fractions to compare, 2/5 and 5/8. We're comparing both of those to 1/2. So in terms of money, I want you to think of fractions of a pound. So half of £1 would be 50p. So what we can do is think of it in terms of which one is going to be closest to 50p. So first up, let's have a look at 2/5. Well, 2/5 of a pound. First of all, we can find 1/5. So 1/5 of a pound is £1 divided by 5. So how many fives would fit into £1? Make sure the decimals line up top and bottom. 5s into 1 doesn't go, and so the remainder first of all is 1. Now we have 5s into 10, which goes twice, no remainder, and 5s into the final 0 is 0. So 2/5 of £1. Well, 1/5 is 0.20, 20 pence. So multiply that by 2, and we'd have 0.40. So we've got 1/2 of a pound. Now we just worked out 2/5 of a pound. Now the final one, 5/8 of a pound, we can work out in a second. So 2/5 is the same as 40p. Just going back to that one for a second before we forget to put the pound sign in. Now 5/8 of a pound. First of all, we can work out 1/8 of a number by dividing it by 8. So how many 8s fit into £1? Well, 8s into 1 doesn't go, so the remainder, yet again, is still all of that 1, which hasn't been used. 8 into 10 now goes once, with 2 left over. 8 into 20, well, 2 8s are 16. Now we need some more space to put more remainders, so just add in as many zeros as you need. So I'll just put another 0 in. Then we can say remainder 4. And finally, how many 8s in 40? That's 5. And so 1/8 of a pound would be about 12.5 pence. Well, it wouldn't be 12.5 pence. So 5/8 would be 5 times 0.125. And so if you did 5 times 125, you'd get 625. Putting the decimal back in, that'd be 0.625. So if we rounded it to the nearest penny, the 5 would make the 2 round up to a 3. So that would be 0.63 to the nearest penny. So how far away is that from half, which is 50? That's about 13 pence away. Whereas 2/5 of a pound is only 10p away from 50p. So which one's closer to half a pound? It's 2/5. So for that reason, we could say that 2/5 is closer than 5/8. And so that would be valid enough working. So our answer, with this working to back us up, would be 2/5. I did mention I'd show another way. And this way we're going to use the idea of equivalent fractions. So we can compare fractions directly if we can make the bottom numbers the same. So here, these fractions have 5, 8 and 2 as the bottom numbers. So you can either write out the 5 times table and the 8 times table and the 2 times table and keep going until you see which number is in all of these times tables, or you can just think about it for a second. It's always best to start with the biggest times table. 8, 16, 16 is not in the 5 times table. Next 8 is 24, that's 3/8. 24 isn't in the 5 times table. 32 still isn't in the 5 times table, but 8 times 5, which is 40, is in the 5 times table, and it's in the 2 times table. And so what we could do is change all these fractions to being fractions out of 40. Once the denominators are the same, if the bottom numbers are the same, we can just simply compare the top numbers, the numerators. So how can I change from 8 to 40? What we could do is multiply the 8 by 5, therefore multiply the top number by 5. So 5 times 5, that would be the same as 25/40ths. Now how do we go from 5 to 40? What would we need to multiply 5 by to get to 40? Well, 5 times 8 would get us to 40. But again, if we multiply the bottom number by 8, we need to do the same to the top number. So 2 multiplied by 8 would give us 16. And finally, halves into 40. Well, how many times can we fit 2 into 40? We could just do 40 divided by 2 to find the answer directly. It would be 20. 2 multiplied by 20 would get us to 40. If we multiply the bottom number by 20, we do the same to the top. So 1 multiplied by 20 becomes 20. So we're comparing both of these initial fractions to a half. Bottom numbers are the same in all fractions, so we can just compare the tops. Which one of the first two is closest to 20? Well, 5/8 is 5 away from 20, but 2/5, this numerator, 16, is only 4 away from 20. 4 away is closer than being 5 away, so again, for that reason, the closest one to it, to a half, would be 2/5. Question 23. We have a scatter graph that shows the number of driving lessons and the number of tests needed to pass by 10 people. And we're asked what proportion of the 10 people passed on their first test. Not how many people passed on their first test. The big clue here is asking us for what proportion passed. So by proportion, we'll mean either a fraction or a percentage. So on the first test, what we need to do is find what the first test would be. The first test means the number of tests that particular person needed to pass would be 1. And so what we need to do is have a look at how many passed on the first time. So if we just follow the graph over, you'll see that there's 3 different people who passed first time. So the answer to this first one is 3. Now with a scatter graph, you can bet almost anything that at some point it's going to involve doing a line of best fit. So I'm going to jump the gun and do a line of best fit here for part B. It says describe the correlation. Now, if your line of best fit is going up, it's going to be positive correlation. So it's not going to be the last two. so we can mark those off. The line is going up as you look at it from left to right. Now, strong positive means if the points tend to be quite close to the line. Weak is if the points are scattered loosely around the line but aren't all particularly close. All of these points here fit on or very close to the line itself, and so that means the correlation is strong and positive because of its direction. And so for this one, we can say it's strong positive correlation. Part C, we can use this line of best fit now to estimate the number of tests needed to pass by a person who has 50 lessons. And so if they had 50 lessons, what we can do is we can go along at 50, go up until we hit the line. When we hit the line, we can go along and see what we get. And so that's between 3 and 4, but closer to 4. So if we could have a decimal number of tests, it would be 3.8. But to the nearest number of tests, because obviously you either have a test or you don't, that would be 4 tests. So because the question says use the line of best fit, you've got to draw it, and then you've got to show evidence of actually using the line of best fit correctly. So by that, what we need to do is we go to 50 and read up and along until we get to the y-axis, which tells us that to the nearest whole number it's 4 tests. Now, for part D, Mira claims that she can use this trend to predict the number of driving tests needed to pass for any number of driving lessons, and we need to comment on her statement. The main thing here is she's saying for any number. So she's implying that this trend can be used for any number of driving lessons, from 25 to 0 all the way up to thousands. So comment on her statement. I just want us to think about if we had our line here and extended it slightly further down. So I'm going to get the line and just move it slightly further down. This is called extrapolating, when you move the line beyond the points which told you to draw the line in the first place. So if you have a look here, using her idea, it would seem that a person who has 25 driving lessons would mean they needed 0 tests to pass, which is obviously impossible because you need at least 1 test to pass. You can't pass a test without doing a test. And so sometimes this is going to give ridiculous answers. So comment on her statement. We need to say clearly but politely to Mira, because we don't want to hurt her feelings, we need to say that her statement is false, and then we can give an example of why it may be false. For example, the reason I've just given. Her statement is false. For example, continuing the trend, horrible writing, continuing the trend would imply that someone taking 25 lessons needs 0 tests. And simply put, this makes no sense. And so that'll do for a reason for part D. Forgive my horrible writing if you can. Thank you. Okay, question 24. A shape is made from rectangles. So we've got 5 different rectangles here, and the letters represent the side lengths. So this one's A long, B wide, and so on. The first question says, on the diagram below, shade an area represented by the expression AB. Well, AB will mean A multiplied by B, because remember with algebra, if you've got 2 different things next to each other on the same line, it just means one multiplied by the other. There's no need for the multiplication sign. And also, what this question is talking about is area. So an area represented by AB, which is A times B, one number multiplied by another. These shapes are rectangles as well. So area, rectangles, it should make you think, well, what's the area of a rectangle? The area of a rectangle is the length times the width. And so what the question is actually asking you for is to identify just one rectangle with a length of A and a width of B, because if we can find a rectangle with a length of A and a width of B, or the other way around, a length of B and a width of A, its area will be A multiplied by B, which is AB. So if we look here, we should be able to find quite easily a rectangle that's A long and B wide. In fact, the top one here will do the trick just fine. So it says shade it in. So with a black pen you could just sort of dot it in. I'm just doing it in green. So that top one represents AB. Now you could have also, if you wanted, have shaded in the bottom one. This one again would also have been AB. So there is a rectangle which would have an area of AB. Part B, on the diagram below, shade an area represented by the expression AD plus CD. So we could treat this as 2 separate rectangles. And so, just like before, can we find a rectangle with an area of AD? So which triangle is A long and D wide? Well, D is a middle width and A is a middle length, and so AD is actually this middle rectangle. So I shouldn't really go over the lines like I am doing, but just colouring it as best I can. And then after we've done that, we need to find a rectangle which is C long and D wide. C long and D wide could be either of these 2 end ones. Each one is C by D, which would give an area of CD. So either colour in the left one or colour in the right one. It doesn't matter, but you do need to colour in one of them. And so this would be a valid answer. So the middle rectangle with either the left or the right one as well coloured in too, but not both of them coloured in, just one of them. Now on C, it says on the diagram below, shade the area represented by the expression D brackets A plus 2C. And so we could actually leave it like that if we wanted. D and the first bracket, there's nothing in between. So you could think of that as D multiplied by the whole of A plus 2C. This is 1C. This is the second C. And A is in the middle. So this whole length is the same as A plus 2C. But I think it's easier if you just expand brackets. Typically it is easier if we expand brackets. So expand this one out here. You get D multiplied by A, which is DA, or AD, plus 2 C, D. And so we need to find a rectangle which is D wide and A long. DA is the same as AD before, so it'll be the middle one. Just taking the care to colour it in without, I was going to say without going over the lines, and I just did. Silly me. As long as you don't go over the lines massively, the examiner should let you off. But do take care to do it as accurately as you can without going over the lines if possible. Now, before, for part B, we coloured in one CD. Now what we're doing is colouring in 2 lots of CD. And so one lot of CD is here. And the other rectangle, which is CD, is on the right hand side. So we need to be colouring in both of these. So that's those both coloured in. And then if we have a look at D, write down an expression for the area of the whole shape. Well, first of all, we could just label each one. So this one here is A times B, which is AB, as is the bottom one. So it's just putting together parts A, B and C. So AB, this is the same as one we had from part A, the top one and the bottom one. The middle one we said was AD or DA, depending on which way around you want to do it. Normally alphabetical order is best. And these two ones here are both CD. And so we have different combinations of letters to add together. There's 3 different combinations we've got here. The first combination is AB. Second combination is CD. We've got 2 CDs and 2 ABs. And the final one, AD, we've just got one of. And so for total expression, we've got 2 lots of AB, plus we've got 2 lots of CD, plus 1 lot of AD. And that's the final expression, which completes question 24. Question 25. We have a distance time graph. Alan, Ben and Carl ran a 1,000 metre race, and there's a distance time graph showing the race itself. The key thing to remember here is that the race was 1,000 metres, and so when we get to 1,000 metres, that means the race is over. So I'm just going to draw a line across 1,000 metres. Now time is flowing in the direction left to right. If we look here, 0, half a minute, 1 minute, and so time is going in this direction. So this is earlier, this is later, and so if we have a look who hits the line first, who hits the 1,000 metre finish line first in terms of the earliest time, it's this line here, which if we trace it back and down, it's Ben. And so who wins the race? The answer to that one is Ben. And we could say why in terms of just giving times. So we can just simply say he got to 1,000 metres first, or if you have a look at the actual times in which they finished, Ben finished in 4.5 minutes, whereas Alan and Carl finished after 5 minutes, so he was a good half a minute before them. So if we just write that down, something along the lines of Ben took 4.5 minutes, Then just say that Alan and Carl took longer. Took 5 minutes. Part B of this question is open-ended, and I'll be honest, I wouldn't like to be faced with this in an exam, but not because it's hard, but because it's so open-ended. Describe the race. Well, the best thing I can suggest is just to be as factual as possible. So let's have a look at it, and I'll try and talk you through it as best I can. So if we have a look here, they all set off together, don't they? 0, 0, the starting point for all of them is the same. So they set off together, and if we have a look, the positions are the same. Alan, Ben, Carl. The positions stay the same all the way up to this point here. So at 4 minutes, it begins to change. So we can put this into words. I'm not going to make you suffer through my scrawling handwriting, so I'll just give you a brief of what I would put down. So I'd be tempted to say something like Alan, Ben, and Carl set off together, because they did, and for the entire first 4 minutes, Alan was leading, Ben second, and Carl was coming last. But if we have a look what happens after 3 minutes, if we have a look, in fact, yeah, after 3 minutes, Alan's speed slows down. It actually stops for a bit. At 3 minutes he stops, and then carries on much slower. So, at 3 minutes, Alan stops briefly, because the line's flat, and then carries on at a slower speed than before. But Ben, look at Ben, Ben changes at around 3.5 minutes. Ben gets faster at about 3.5 minutes. He's not the only one, as does Carl if you have a look. Carl's going steady up until 4 minutes, and at 4 minutes he picks up the pace too. I'm just saying, Ben gets faster at 3.5 minutes, as does Carl after 4 minutes. So because Alan slows down, the other two speed up, what happens is soon, whoops, put soon twice, soon Ben overtakes Alan after about 4.3 minutes or so on the diagram. It's hard to see exactly. And carries on to win the race. Carl, because he's going faster, Carl carries on catching up Alan. So he keeps catching up Alan, and eventually ties level with him. And they both finish together. If you look there, they both finish at the exact same time at 5 minutes. They both finish together after 5 minutes from the start. So quite a mouthful really. I'm not saying that's the only way or even the easiest way perhaps of explaining it, but that's just a way that comes into my head in terms of what happens with A, B and C. Keeping it relatively simple where I can, but also sticking to the facts of the graph. You don't want to be making things up or imagining what happens. Bit of a nasty question, I think. Pretty hard, but the main thing is, for 4 marks, try to make 4 obvious points. Definitely commenting on the beginning, the end, who finishes first, second, third, and also what goes on in the middle of a race. So try and make 4 brief points. Try and imagine it's 1 mark per point. Question 26. 2 straight lines are shown. A is a midpoint of OB. So if you have a look at OB, let's work out what we're talking about. So OB, if every line's given as 2 letters next to each other, that means it's a line from one letter to the other. So OB will mean a line starting at O and extending to B. So that's the line OB. It also mentions the line TS. So if I have a look at TS, TS means we start at T. Oops, I'll get a slightly thinner line for this one. So as I was saying, we start at T and carry on all the way down until we get to S. So we now need to work out the coordinates of T. So let's just take it step by step. We're told here that A is the midpoint of OB. So A is in the middle of this yellow line. The yellow line starts from the origin. And so the origin just simply means this point here, which is 0, 0. If we have a look at A, it's 7, 6. So that means from O to A, we must have gone 7 along and 6 up. So from O to A means 7 along and 6 up. So I'll just put these numbers in. So 7 along, 6 up to get us to A, which is 7, 6. But we're told that A is the midpoint, and so going from O to A is only half the way along. So to go the full way along, from A to B, would require doing the same again. If 7 and 6 is halfway, then we'll need to do another 7 and another 6 to get to B. Another way of thinking about this is we can just double the coordinates of A in this case. So 7 plus another 7 gets us to B, so B must be 14 along, and the y coordinate of B, we go 6 up, then another 6 up, which will be 12. So B has to be 14 and 12. And now we know B, we can have a look at what it says about B. It says B is a midpoint of TS. So because B is a midpoint of TS, what that means is we can start at the point we know, which is S, and imagining working backwards towards B. So S is the point where x is 25. Here, x is now 14. And y has gone from 4 up to 12 if we work back. So let's do y first. So we've gone up from 4 to 12, which means we must have gone 8 up. And as I said earlier, with x, we're going from 25 down to 14. The difference between 25 and 14 is 11. So that's 8 up and 11 along. But of course, because B is only the midpoint of TS, to get from B to T, we'd need to do exactly the same again, effectively doubling the distance of 8 up, 11 along. So if we do the same again, and go yet another 8 up, and yet another 11 along, that will get us to T. So another 8 up, another 11 along. Well, B is already 14 and 12. So if we're working out the coordinates of T, 25 back to B took us to 14, another 11 to the left, 14 subtract 11 would mean that this coordinate is 3. And the y coordinate, going from S backwards to T, we're going up the line, we're going up and back. So from 4 up to B, from 4 to 12 is a rise of 8, then we make another rise of 8 from 12. So 12 added to another 8 would be 20. And so that tells us that the coordinates of T must be 3 and 20. 27. We've got 3 straight lines. Importantly as well, notice that these 2 lines here are parallel. That's going to be very important, so I'm just going to highlight the fact that 2 of these lines we're given are parallel, because as we should know, there are some parallel angle facts we can employ and use. So let's have a look at the angles we've been given. Well, we can do this a couple of different ways really. What I'd suggest we could do is notice that if this is 2x plus 15, then the angle vertically opposite it will also be 2x plus 15. The reason is vertically opposite angles are equal. So if this one's 2x plus 15, the one opposite will have to be exactly the same. So I'll just fairly briefly colour code this in, just so we know why they're matching up. So the main reason is the vertically opposite angles are equal. Now what we can do is try to spot other angle facts. So if we have a look here, we can make an F shape with these 2 lines. And so if I start over here and do a straight line going downwards, and do the same along the parallel lines, then hopefully we'll remember that corresponding angles, which I tend to call F angles because they look like an F, are equal. The armpits of the F are the same when the arms are parallel, which in this case they are. So the main thing we're getting at here is that this angle here, 2x plus 15, is exactly the same as 3x minus 38, and so that's our way into solving this. 2x plus 15 equals 3x minus 38. Now, when we've got an equation with x's on both sides of the equals, what we need to do is to get all the x's on one side and all the units on the other side. And so what I'd suggest doing is taking away the smallest number of x's. So we can pick 3x or 2x. The reason I mention this is because it avoids negative numbers, which are always slightly more confusing just by the nature of them. So what I could do is get rid of this 2x. Now your tutor or teacher may be saying what you do to one side you do to the other. So actually what's happening is we're going to take 2x from each side. If I subtract 2x from the left hand side of the equation, 2x take away 2x will leave us with no x's and just with 15. But if we do that to the left, we have to do the same to the right. So 3x take away 2x, we'll be left with 1x. A shorthand way of explaining this is it seems like the 2x is going to swap side and swap sign. The 2x as it stands is positive. When it moves over, it'll become minus. And so over on the left, we'll just be left with 15. On this side, 3x take away the 2x, leaves us with just 1x, and minus 38. We're almost done. We just need to bring this minus 38 over to the other side to join the 15. Now, that minus, when it swaps side, will become the opposite of what it is right now. Opposite of minus is plus. And so on the right hand side we'll just have x on its own, which was our objective after all. And on the other side, 15 plus 38, which you should get, comes to 53. So the value of x is that x must equal 53. Now, it is possible, of course, that when you get to the exam, heaven forbid, you've forgotten your angle facts. So where could you start if you really had no idea about how these angles related? I'm going to give you a hint or a strategy, and it really is a last case or worst case scenario. So I'm not recommending you do this unless you're really desperate. But where it says the diagram's not drawn accurately, that's often true. However, usually the diagrams aren't drawn terribly, so they're normally going to be a bit accurate and not entirely wild. As I say, take what I've just said with about a metric ton of salt. This is a worst case scenario. What I'm suggesting is you can measure the angles just to give yourself a clue only. You can't measure and assume they're going to be 100% accurate, but you might get some inspiration from them. So for example, measuring this angle here for 2x plus 15, if we just swizzle the protractor around, measuring up from 0, 2x plus 15, 10, 20, 30, 40, 70, 80, 90, 100. That's about 120 by the looks of things. And if we measure this one down here, so again, need to spin it round so we're measuring it in the right way. If nothing else, it's a good excuse to practice measuring angles. So starting from 0 at this end until we get to the other side, that green line, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120-ish as well. So even though it does say not drawn accurately, and even though I'll say again, I'm not recommending you do it unless it's a last resort, you could measure the angles, because that might just give you a clue or a nudge. Something might just click in your brain. Ah, maybe they're equal. Maybe 2x plus 15 is the same as 3x minus 38. And if you do that and guess that as a worst case scenario, there's a chance you can solve an equation and get some credit rather than being stopped at the very beginning and prevented from getting any marks at all because you've forgotten your angle facts. So just bear that in mind as a strategy if you're really, really desperate. Question 28. Dreaded simultaneous equations. We have to work out the values of x and of y. What we'll need to do is to get either the number of x's or the number of y's the same in both the top equation and the bottom equation. If we look here though, at the top we've got 2 x's, the bottom one we've got only 1 x, and at the top we have 3y, but down here only one y. So just to remind you, if there's no number in front of a letter, you can assume there's an invisible 1 in front. Now forgetting the signs, if it's plus or minus, right now that doesn't matter, but what we do need is either these two numbers to be the same, or those two numbers to be the same. So what I'm going to suggest is we keep the top one as it is. So I'm just going to copy it out here, nice, big and clear. But what I'm suggesting we could do to the bottom one would be to double absolutely everything. So if we take the x's, the y's and the number and just multiply every single thing in this equation by 2, what we'll get is we'll have 2 x's in the bottom equation as well as the top, and that's all we're after. So 1x times 2 would give us 2x. 1y multiplied by 2 becomes 2y. And the number 6 multiplied by 2 becomes 12. So why do we want the x's or the y's to be the same? Well, the whole idea is simultaneous equations are hard because you've not just got one unknown to deal with, you've got two. Normally with equations you've got just an x or just a y or just an a or whatever. Here you've got two different things to deal with. But if we can get the number of x's or the number of y's to be the same, in this case it's the number of x's, we now have a chance of just getting rid of the x's altogether. Then we can focus on the y's without having to be distracted by another problem with the x's. What I mean by that is, if you notice 2x on the top and 2x on the bottom, and just think, well, what if I subtracted all of what's on the top equation? Sorry, if I subtracted the bottom equation away from the top, what would happen to the x's? Well, if we had 2x on the top equation and we subtracted 2x, we'd have no x's left, which is exactly what we want. 2x take away 2x would be no x's, which is fantastic. No x's to worry about. Moving on to the y's. At the top we have 3y. If we take away these 2 y's, that will leave us with just 1 y. And do the same with the numbers at the end. 15.5 take away 12 would leave us with 3.5. So by eliminating x, we've managed to isolate y on its own, and we've come to the conclusion that y must be 3.5, which is great, because now that's our way in to finding out what x is as well. So y equals 3.5. May as well put that one down. Now we know that y is 3.5, we can pick one of the first equations and just substitute the value of y back into it. So the first equation was just simply x plus y equals 6. But now, because we know that y is 3.5, what we can do is replace y with what y actually is numerically. Y is 3.5. So x plus y equals 6 just becomes x plus 3.5 equals 6, because y is 3.5. Now we need to rearrange this equation to solve what x is. We want to have x on its own. So obviously that 3.5 we don't want. And as you may have heard me in class say time and time again, credit to Simon Ferris, who also uses this way, if you swap the side, we swap the sign. So move this positive 3.5 over to join the 6, and it will change from a plus to a minus. So x is going to be 6 take away 3.5, which would be 2.5. These need to be practiced a lot to be mastered, but That's how you do this particular one. Now we move on to the final question of the paper. So don't expect it to be easy. It says in the diagram the area of triangle ABD is 56 centimeters squared. Now ABD just means the triangle we get from moving from A to B to D. So from A to B to D is just this triangle here. So it's not the whole triangle, it's just one on the left hand side. We're told to work out the length of CD, so what we're wanting is to work out CD on the other side, which is this one here. So, area of a triangle. Well, what we need to remember is how we work out the area of a triangle. So, you need to recall that the area of a triangle is half multiplied by the base multiplied by the height. So what we can do is put into this equation what we have been told. So there's three different things. There's one thing which is the actual area of the triangle. The second thing we are interested in is its base. Lastly, we're also interested in knowing its height. So, the area of a triangle, we're told that, so that's 56. And we're also told the base. So half multiplied by the base. The base just means the bottom part of a triangle, which we can see from here is 14. So the base is 14. And the height, well, the height we don't know, but let's think about what the height means. The height means all the way from the top to the bottom. So for this particular one, the height means all the way from B to D. Which is this length here. So we still need to work out the height. So let's call the height H, because I'm lacking in imagination these days. Anyway, never mind. So what we can do now is try to simplify this down. Half multiplied by 14 multiplied by H. So let's work out what we can first of all. We can do half times 14, because that just means half of 14. Half of 14 is 7. And then times by H. Now we can think of this as an equation if you'd like. 56 equals 7 multiplied by H. You could even do it by trial and error and just be thinking of different numbers you could multiply 7 by to get 56. Well, the actual answer would be 7 multiplied by 8. So that's one way you can see that H has to be 8. Another way, though, treating it as an equation, is we need to get the H on its own. That 7 is multiplying the H. So if we just get H on its own and swap this 7 to the other side, we'll swap the side and swap its sign from being a multiplication to a dividing. So H will be 56 divided by 7. How many 7s fit into 56? Again, it would be 8. So the height equals 8. So how does that help us? Well, now what we can do, we can actually ignore the triangle we've just been looking at and just focus entirely on this one here. So just to make sure this isn't a distraction anymore, I'm I'm just going to take it and just scribble it away. We're done with this side, so let's just remove it as neatly as I dare without rubbing out the important bit of information. Right, that'll do. Now just focus on what's left. What sort of triangle is it? It's a right-angled triangle. We know one side and a second side. We want to work out the longest side. Right-angled triangle, a theorem of somebody famous for working out lengths of sides. This one is a classic Pythagoras question. So alarm bells should go off. Can't even spell Pythagoras, that is shocking. I can, but my mind's all over the place. Anyway, sorry Mr. Pythagoras, no disrespect meant. So, we can label the longest side h for hypotenuse. Your teacher might be saying it's a squared plus b squared equals c squared, or c squared equals a squared plus b squared. There's lots of different variations on this same formula, but ultimately what happens is the longest side squared equals the sum of the two shorter sides in any order squared and added together. So one short side is 8, so square that, and the other short side is 6, so square that too. Now you might be thinking, oh, Pythagoras on a non-calculator paper. Well, it can happen, but fingers crossed, maybe this number will be a whole number or easy to deal with. So let's see. So we can work out what 8 squared is. So 8 squared just means 8 times 8, which is 64. 6 squared means 6 times 6, which is 36. So now we can just add these together. Remember, BIDMAS always applies. We've worked out the powers, now we can add them together. So h squared, by the way, is CD. So if that hasn't been clear to you, I'll try and make it clear there. So h squared equals 64 plus 36. So either way around you do it, you should get 100, but let's just see. 4 plus 6 is 10. Put the 0, carry 1 along. And finally, 6 plus 3 is 9, plus a carried 1 is 10. So h squared equals 100. The final step with Pythagoras is to always take the square root. So finally, h, which equaled CD all along, will be the square root of 100. So the square root of 100 means what number, when we multiply it by itself, gives us 100? Well, the answer to that is 10, because 10 times 10 is 100. So the final answer, after all that hard work, has paid off, and we've got our answer for h, which is side CD, equals 10. So finally we can breathe a big sigh of relief, put down 10, and then go back and look through your other questions. So I do hope you found some of those questions useful. Look through them, ask your teacher. If you're unsure, get it to be marked, and keep practicing whatever you do. Keep practicing. Thanks for listening, and I'll see you again soon.